So for today, we are going to be doing what's called linear programming. Sounds really scary. It starts with something really easy, which is just graphing inequalities. So on a two-dimensional graph like this, I asked the students to graph this. How many of you are confident? Raise your hand if you're confident you've got this right. Only like 3 people, I get it. So here's a couple things that'll help you dial in on whether you're doing this right or not. This is a line. It's not a place. It's not like, oh, I found the number 3. Okay, it's a line. And it's shaded either above or below or left or right of the line. How many of you are on the right track so far? Okay, a few of you. All right. Next thing is, what the heck is the y direction? Well, I remember it this way. This is the y-axis. But this line that runs right through that is not y equals. That's x equals 0. X equals 0 is a line that runs that way. So this is the x-axis. So it's not x equals something, it's y equals 0. Does that give you a hint? It should. Because now that you know where y equals 0 is, you should be able to graph where y is greater than 3. Now I should get it up to at least half the class. Should know where y equals 3 is. And then you're shading it, and then you're going to actually want bigger than 3. Now how many of you are confident? We're up to about the third of the class. All right, so here's y equals 3. That's the line y equals 3. I mean, that depends on what you count by, but I'd say that's about 3. And then, should it be solid? No, it should be dotted line. Did anybody actually remember that? Ah, nice, like 5 people remembered that, good. And then greater than 3 shades above it. Greater is bigger, and that makes sense. There you go. The green line that's dotted with shading above it is what you were looking for. I know you graphed that a long time ago. It was definitely not in geometry last year, so it was at least a year ago, probably 2 years ago. So let's see if you can do it now. If I say I want x to be greater than 4 and y to be less than 3 or equal to 3, can you put those on the same axes? Remember, if you go, well, the x-axis is here, that's not x equals 0, it's y equals 0. Let that guide you. It's the x-axis, but it's y equals 0. So, and then one of these is or equal to, which means one of them it's got a different, like one of them's got to be dotted and one of them's got to be shaded. You got that down? All right, so first off, the x-axis is where y equals 0. Y is actually 3 in this case, so I'm going to put another line at 3, but this time it's a solid line at 3. You with me there? And then it says less than, which means I'm going to shade underneath that line. But if on the same graph, I were to graph x is 4, first of all, that's like the y-axis direction. But that would be x equals 0, and if x equals 4, it'd be like over here. But what's wrong with what I just did? It needs to be dotted because it says greater than, not equal to, just greater than this, so it can't be this. Things that are on this line don't work. And then greater than 4. So I'm shading just a little bit in this direction. Notice I'm not trying to shade across the whole graph. It just gets too messy. Trust me, I've done these a long time. A little bit of shading on one side of the line is way better. And at the end, this is your answer. It's points that are in the shaded region, shaded in both directions. Cool. In under 5 minutes, I just taught you everything you need to know for today's homework. If you feel a little overwhelmed, it's because I just did the fire hose of information. That's really what you have to know for today. Is can you graph 2 things, shade them properly, and then figure out where they overlap. Where they overlap has got a special name. It's called the feasible region. Because a point in here, let me pick this point like right there. That point right there. It's shaded both directions properly. It might be the number like 10, 1. That point right there would work in both cases. Its x is bigger than 4, see? And its y is less than 3, right? So it's feasible. If I asked you to jump 5 feet in the air, is that feasible for a human?
No.
Might not be feasible for most of you, but have you heard of the high jump?
Yes.
Do you know the record high jump is way higher than 5 feet? Like 7 feet, something like that? All right, so it's feasible a person could jump 5 feet. I know, it seems crazy, but the high jump, that's what they do. So feasible means can you do it or not? All right, is this point right here feasible? Yeah, because it's shaded in both proper directions. So whatever it is, it probably works in both equations. Like if it was 9, -3, you could look at its x value and go, is its x value really bigger than 4? It is. Is its y value really less than 3 or equal to 3? And it is. Okay, cool. Is this point right here in the feasible region? That point right there? No, it's not. And therefore, it may work in one equation, but not the other. Or it won't work in either one. In this case, it won't work in either one. All right, awesome. So let's see if you've got this. Typical question. Y less than or equal to 4, x greater than 3. Graph and find the feasible region. Let's try that one idea again on the board. The y-axis is like this, but that's x equals 0. So x equals 3 would be here, and I don't want it to be a solid line, I want it to be a dotted line because it doesn't say or equal to. Are you on the right track so far? And then y is less than or equal to 4. Well, here's 4. And it's a solid line because it says or equal to. And it's less than this. It was bigger than 3. No, wait. Oh, yeah, that is right. Oh, my gosh, it's pretty much the same place as last time. All right. Now, what if I had said 4x minus 5? Oh, that's just impossible. No, that's really not that impossible. Which line needs to change? Careful now. The horizontal line need to change, or does the vertical line need to change? He says this one needs to change. Do you guys agree?
Yeah.
Yep. So let's erase that line out. Everybody erase that line out. Now it's got to be 4x minus 5. Kind of remember that that's a slope and a y-intercept? Remember this deal where that's the slope and that's the y-intercept? So it starts down here at -5 and then it has a slope of rise 4, run 1, rise 4, run 1. And it would look something like that. Is it a solid line? You can tell by this. Is it a solid line? Yes, it is a solid line. If it has an or equals, it's supposed to be a solid line. Then it says less than. Now it's trickier when they're at an angle, so I'll give you this. If it's less than, it's under it. For some kids, they do not get what's the underside of that black line. Most kids will get it. The underside, the less side, is this way. That's below the line. Now, where's the feasible region? Very common for kids to think that this point right here is in the feasible region. Is it? No, it's not. Is this point over here, careful, is that point over there in the feasible region? Is it shaded correctly in both directions? Yeah, that's in the feasible region. How about a dot up here? Is that in the feasible region? Up here. Yep, that's in the feasible region. It's shaded both correctly in both directions. I could give you an example. Let's say that that was the point 7 comma 6. You could check it. The x has to be bigger than 3, is it? Yep. And the y has to be, oh, that's gross. This 6, I'd have to go put it over in, the 6 has to go into the equation for the y, and then I'd have to see about the x also. See, this also has x in the equation, right? And I'd have to see if that worked. 4 times 7 is 28. 28 minus 5. 28 minus 5 is 23. Is 6 less than or equal to 23? It worked. All right. Last thing for today. If you had to pick the most important spot on these graphs, it will be where the two lines crossed each other. You're going to find out that when I shade the double shaded region in, I'm going to do these blue streaky lines here for it. That's the feasible region. That the corner of the feasible region, also known as the vertex of the feasible region, that's where the answers are always going to be to the problems that we ask you. We're going to ask you some word problems. By the end of this unit, instead of just graphing equations, you're going to have to make the equations out of words, like Bob goes and rents a chainsaw, and the chainsaw costs this much per hour, and then you write this equation, then you're going to graph the equations, and then you're going to realize that the corner is always where the answer comes out. Sometimes there's more than one corner, and then you got to figure out which corner makes the most profit, or minimizes and it has the least in costs. I know this is a lot, but that's the whole unit there. That's the big picture of everything we're going to do for this whole unit. So now, what do you actually have to do for today? Well, you have to know things like that's greater than or equal to. That's less than. That's less than or equal to. And I think you knew those. That's why I kind of glossed over those. Let's go to the next page. If we just had to do it on a number line, let's say this is 10, more than 10, you'd go like that. But we don't really do just number lines in this. We get to X and Y axes graphs. So I got to those right away. So let's go to those. Two variables, see. Now let's see if you can write an equation. Let X be the strawberry jelly beans. And Y is going to be the lemon jelly beans. And you're supposed to write an equation. Well, obviously it involves X and Y. And 9 times out of 10, you're adding the X and the Y, and then it's less than or equal to a number. That's how they usually work. Okay, well, let's see what this one is. Your mom went to the grocery store to buy jelly beans. She wants less than 5 pounds of strawberry. Ooh, that's just involving one of the variables. Which one is it? Which one's strawberry? X. And she wants you to get less than 5 pounds. X is less than 5. That's pretty easy. At most 2 pounds of lemon. Why? At most 2. That one confuses people. Is that greater than or equal to or less than or equal to? At most. The most it can be is 2. Do you get that's really less than or equal to? At most. The most it can be is 2. So then it's really less than or equal to 2. All right, cool. And then we'd actually graph them. Now, we've already done enough of those that I don't think we need to do another one. Oh, here's one that's already been done. See how they shaded? These get really hard to read. So that's why, in my opinion, you just shade a little bit on this side of the line instead of like just washing the whole thing with like blue. And then you just shade a little bit on this side of this line. Otherwise, then you get into the thing where 2 colors have to mix, and like, what color is it when these 2 colors mix? And it gets really complicated. I think just shade a little bit. All right. Now, here's a plain old easy one, except didn't I have it y equals last time? So what could you do to make this just y equals? What would be your first step? Minus 4. Minus 4. Negative y is less than or equal to x minus 4. Is it ready to graph yet? Now, how do I get the negative off of there? You can divide by a negative, but that's harder. What's easier? Wouldn't multiplying by a negative also get rid of it? And multiplying is easier than dividing, isn't it? So we're going to multiply everything by a negative. Y less than or equal to negative x plus 4. I just changed all the signs. Does anybody know what mistake I just made? Yes. When you multiply by a negative or divide by a negative, you got to switch the sign around. So I was hoping somebody would notice. I knew when I was doing it. Sometimes I just make mistakes. This time, I was going to see if anybody noticed. You see how it switched? If you multiply by a negative, everything has to become opposite, including the sign. Now, could you graph that? Do it. You know what the y-intercept is? You know what the slope is? This is a good review of tons of algebra. All right, compare with the kid next to you. See if you got the same graph. Goes through that spot. Did you think through whether or not you wanted solid or dotted? And do you know what a -1 slope does? All right, please talk to the kid next to you. I'm going to pause while you do that. All right, let's see how you did. So this is going, I would like to think of this as -1 over 1, because then I get a rise and a run. So it goes down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. And then I got to start thinking, do I want to have this have a solid line or a dotted line through it? Since it's or equal to, granted it switched the other way there, I want it to be a solid line through that. And unfortunately, I just lost all the dots, and those are important. I'm putting them back in here. And then, which way should I shade? It says greater, so you shade above the line. How many of you had that exactly perfect? Cool. All right, do you get that on other problems, we will sometimes have a line like this, and it'll shade under it. And then we'll sometimes have a line like this, and you shade like to the left of it. And do you get how you end up with this region. What did I call that again? The feasible region. Good. And the corners of that are technically not called corners. Do you remember what they're called? Vertices or vertexes or the vertex. Yep. The answer to your word problems, the hard ones at the end, will always be the corners, the vertices of the feasible region. Now, if you wanted to maximize profit, you'd have to figure out how much profit do you make on each X, how much profit do you make on each Y, and then you could figure out whether this one gave you the most profit or that one gave you the most profit or that one. And usually to get the biggest profit, you want up and to the right. All right. What if you want the least number? Down and to the left. Of course, 0, 0 is the least you could have in the real world. The expenses are 0 at 0, and so bottom line is these are generally where you're maximizing things. The bigger is in the upper right, and near 0, 0 is of course getting close to minimizing something. What do you want to maximize? Profit. What do you want to minimize? Costs. If you keep your costs down, that's good for a business. If you keep your profits up, it's good for the business. You can keep going. You can keep hiring people and keep making a living. All right. Take a look at this one, please. They've already got something graphed. Do you get that they graphed this red one already? Would you add the black one to it? X is less than or equal to 6. Just put it on the same graph. And then do what I said about just shading a little bit. Don't try to darken it all in with a color like they did. I don't think that's the smart way. I'm telling you, I know you're going to do a bunch of these on paper because the actual test is on paper. You don't want to darken it because all you have is a pencil. And once you darken it all in, then when you want to darken it in again, you can't because you already darkened it in the first time. But if you just shade a little bit. All right. How do I know if I'm doing it right? Is that the way these kind of lines go for X? Well, that's the y-axis, and so that's x equals 0, so yeah, that's the right kind of line. Except x equals 6 would be right here. Do I want solid or dotted? Say it if you know it. Solid, good. And then I want to have less than. I hope you know less than is to the left. Now, do you get the feasible region would be right in there then? And do you remember me saying the corners is where the answers are going to be on the word problems? Okay. All right, cool. I think you've learned everything. So this is the part where we get to the homework and you have a lot of time to work. So your homework for today is actual, like it's on a PDF so that you can graph it. You don't want to try to do these on Schoology quizzes. They're a real pain in the butt. So we'll just do this on a PDF. You'll graph it, you'll sketch it, you'll use dotted lines where you're supposed to. Hard to believe how many kids still don't get this. Dotted or solid line? Solid. Solid. All right, good. Is it left of the line or right of the line? Left. What if it was a line like this? Then it wouldn't be x equals 5. What would it be? Y. And what if it was less than 5 and it was going like that? All we're good at so far, but which way would I shade? Under it. All right, good. Okay, now find your worksheet. And you're only doing problems 1, 2, and 3. I know, it seems too easy. But each problem has like 3 things you graph. Graph these 3 things, graph these 3 things, graph these 3 things, see where they overlap and stuff. Just doing 1, 2, and 3. And that's all we got. I'm going to pause for a second. Doesn't number 3 end up on the second page?